Hi everyone, I am Professor Jehad Dallal from Gulf University for Science and Technology in Kuwait. On behalf of my colleagues, the research group, I would like to present this work titled An Optimized Stacking Ensemble Learning Model using 3 pyramids technique for the 2006 SHF Groeneveld log table prediction. The presentation is going to start with a brief introduction. Then I will talk about the methodology that we have followed, and then I will describe the data that we have used. Then I'll talk about the results that we got, and finally I will end the presentation by mentioning some conclusions and some future work directions. So SHF stands for critical heat flux. So this is the point at which the heat transfer rate reaches its maximum limit. So we have a lot of applications in which we don't want the heat to exceed a limit, a critical point of that we have, a critical limit or value. Like, for example, if we are doing some nuclear reactions, okay, it's important that the heat does not exceed certain limit. So that limit is called the SHF. Okay, this SHF depends on many factors. So like the pressure and others, I will mention some of these factors. Based on these factors, we are going to have a value for the SHF. So we would like these factors to have certain values such that we make sure that we are not exceeding the limits that we have for SHF. So we have lookup table saying that if the pressure is like this, the mass is whatever, okay, then in this case, this is the SHF that we are going to have. So that table is not going to be a complete table. It is based on scenarios. If we have this pressure, this mass, whatever. But what if we have different values for these? So we have to make more and more experiments to make the lookup table bigger and bigger. So how to build that table? If we are going to build that table based on physical experiments, then this might be potentially a costly thing to be done. So instead of this, we can apply machine learning techniques. Given the data that we have from the experiments, we can train using the machine learning techniques. We can train from these data to predict the SH values for the other scenarios that we didn't do experiments for them. There are a lot of existing works in which we are building such tables using different machine learning techniques. One of the things that which is known in the field of machine learning is that applying a single prediction algorithm potentially features some accuracy limitations. So we might have certain values for accuracy. If we can combine the capabilities of different machine learning techniques, then we can improve that accuracy. Okay. There is already approach or a technique called stacking ensemble learning. In this one, we are combining the results in a certain way from different prediction techniques, from different machine learning algorithms. We are combining the results in a way, and then we are finding the final prediction results. it's open which techniques to use. So in our work, we are using 21 different techniques. These techniques follow different machine learning approaches, such as regression, decision trees, neural networks, and others. When we do the stacking ensemble learning, we do it in 2 levels. So we have level 1 and we have level 0 and level 1, as you can see in this diagram. So in this diagram, you can see that we have 2 levels. So at level 0, we are applying the 21 basic learners, the 21 machine learning techniques, and we are getting the results. And at this level, we are applying the cross validation to train the models that we have. Then we are utilizing the outputs of level 0 models. We are utilizing them as inputs for level 1 model. So at level 1, we are applying linear regression to combine the results that we have, to combine the prediction results and also the original data set. Okay, and by this we are aiming at decreasing the bias that we have and enhancing the accuracy. The problem that we have for the stacking ensemble learning is that it is time consuming. As you can see that we are applying, for example, in our experiment, 21 machine learning techniques. So usually researchers, when they apply stacking ensemble learning, they try to optimize the model to reduce the number of techniques that we are applying. So we are proposing a new optimization technique, which is the 3 pyramids. We are calling it 3 pyramids optimization technique. We are calling it 3 pyramids because, as you can see in the figure here, it is like the Egyptian 3 pyramids. We have the bigger one, the biggest, we have the medium one, and we have the smallest pyramid. So what we are doing here is that we are applying the first one, in which we are considering all the 21, and we are learning from that one. And when we do this learning process, we are trying to find the best 10 techniques in terms of accuracy and error, prediction error. After finding the 10, we consider these to go and do the same thing and applying the stacking ensemble learning, considering only these 10. And then we are reducing this by 50% again. So we are doing the 3rd pyramid that we have, in which we are applying only the best 5 techniques. So instead of 21, we are ending with 5, which means that we are, this is the expectation is that we are reducing the execution time. So this is what we are trying to gain. So our goal is not improving the accuracy is not our goal, but we don't want to have we don't want to lose some performance, but we are trying to reduce the time, okay, the execution time. Okay, so so after mentioning the data description, let's go to the next one here. So I'm facing a problem with the slides. So these are the results. These are the results for the 3 different permits. We have considered 2 measures for the error, RMSE and MAE, and 1 measure for the accuracy, which is R square. You can see that applying the SEL technique is giving us good results in terms of error. So the error is low, and in terms of accuracy, so the accuracy is high. And you can see that by optimizing the technique, we are not losing performance. So the error is almost the same, and the accuracy is actually slightly better. But in terms of time, you can see the big difference between the execution time of the 3 permits. So for the first permit, the execution time is 157.9, almost 158 seconds. And for the third one, it is only 2.1 seconds. So in conclusion, you can see that when we are applying the stacking ensemble learning, when we are combining the results from different learners, we are building a model that performs better overall than any of the included models. And actually, I didn't report the results for the other models that we have, the 21, but it is already reported in the paper, so you can refer to that one. So you can see that the model that we have is better than the others, and this is in terms of accuracy and in terms of prediction error. So we are reducing the prediction error and we are improving the accuracy. We are increasing the accuracy. And from the experiment, we have found that applying the 3 permit technique succeeded in slightly improving the model accuracy, slightly reducing the prediction error, which are not the main goal for applying this optimization, because the main goal is the time. So in terms of time, we significantly reduced the construction time for the model. So the key advantage of this optimization technique is reducing the execution time significantly without any performance loss. So in the future, we can extend the work that we have proposed by considering more base learner algorithms. We have considered 21. We can consider more or others, okay? And we can compare the results with the results that we got. Also, we can apply other optimization techniques and compare the results for the other optimization techniques with the technique that we have applied. Thank you for listening, and you are welcome to ask questions.